Hello, everybody. This is our second week of class, and we're going to start out today by talking about some of the topics in what I call Unit X. And I kind of strategically named this Unit X for a reason. And when you think of X as a character, you often think of like maybe how it relates to math, right? So you learn how to do algebra, for example, and you have to deal with X's and Y's and Z's and A's and B's and C's and stuff. And it's basically a variable. And my thinking on this is one of the great major underpinnings of the whole field of information technology is the people that work within that field, their main purpose for whatever career path they choose, however specific it gets, is to basically be a problem solver. So knowing how problems are solved really becomes kind of a critical thing. So like if your machine gets a blue screen of death, for example, like just happened on one of our workstations here, what do? Do you panic and give up? Take the computer, throw it in the garbage? Take a hammer to it? Some people might. And the reality is, you'll probably start trying to figure out, either based upon what you already know, how to fix it, maybe call a friend who might know, or you start looking up possibilities for resolving it. And that's a process, right? And so for some of us, it comes really naturally. And I don't know if any of you are like that. I certainly have been in my life, and I never really kind of thought about it that way until I realized that as I started studying computers, people would have problems with their computers, and all of a sudden my phone would ring. And it's like, hey, you know a lot about computers. Can you help me fix my whatever, right? And it got me really thinking a lot about these topics. For a long time, I was kind of like the whole extended family. I was like the IT support guy for the whole extended family, right? So whenever they'd have an issue or a virus, they'd give me a call. And now I'm happy to say that my son has taken over that role because he's pretty bright with this stuff too. And so now when grandma and grandpa have a problem, they call my son and he helps them. And you know what? He does a great job of it because he seems to be an intuitive problem solver as well, And some of it does come naturally. So there is kind of like this natural propensity when you see something wrong to fix the problem. And that does not necessarily have to relate to technology. And this is really what's important. Because a lot of the times when you're dealing with a problem, technology problems are generally well documented. And if you can get your hands on a browser and do a search, chances are you'll probably find some information that's going to help you. And so whatever that blue screen of death is that we had on the workstation here this morning, may in fact be something pretty simple. In fact, if you look at those error messages, there'll be a little code. There'll even be like what they have a QR code these days, so you can like look it up. But they'll tell you which thing failed, and you can look it up and see what the possible fix might be. Most often, it's a driver or a hardware failure that's causing it. And so how do you know that? Well, by looking at what the error message says and looking it up, right? But what if it's not documented, right? So what if your situation is, and my silly example often is, right, if you want to build a house, you don't just run down to Menards and buy a bunch of 2x4s, a hammer, and a nail and get busy, right? You start with a plan for how you're going to do it. And to come up with a plan, you really have to think about the problem holistically as one big whole, and then how you're going to break it down into little pieces and solve all the little pieces individually. That's how you do computer programs, by the way, folks. You don't solve it. Somebody just doesn't walk in, spend a couple of hours, and they have a video game, for example. That's not how it works. Chances are they maybe spent a couple of hours and worked on one facial expression for one character in the video game. That's the kind of time that it takes. So let's, I'm going to get into screen sharing mode here. I know my face is up on screen. I never usually like to record like that, but hey, there you go. So this screen is now being shared here that you see up on the screen. So I am in Unit X within our course on Blackboard. And I'm going to talk about a couple of things here. And we're going to begin by just focusing first upon these three words. And I'm highlighting them and pointing them out with intent because this will be a question on your midterm and your final. So I'm telling you right now, it's not a guess, it's a certainty that we discovered through the process of coming up with modern advanced mathematics, mathematicians and logicians, basically, which are people that work on logic, discovered that the three techniques you use to solve any problem, regardless of what area it fits into, is sequence, selection, and repetition. Those are the three tools that we have to solve any problem. And I'm going to do a little bit of demonstrating here what I mean by that. And then we're going to talk about how it applies to computer programming and what techniques you use in computer programming in order to solve a problem and then be able to write a program. Interestingly, when you start to apply these techniques to other paradigms, they sometimes make more sense, which is why like your first assignment is a recipe, right? So nobody thinks of it as a problem-solving exercise, but anybody that's ever cooked, and you may have a recipe sitting in front of you, but you always run into issues with recipes, making them work, so like it could be altitude, it could be ingredients, it could be the time, it could be the tools you have, it could be the materials that are available. And so then what do? Do you just give up, or do you find a way to make it work? And that's really what we're trying to teach you here, is you find a way to make it work. All right, so I'm gonna pull down the PowerPoint here, which I think I already have up and running. And the first thing I'm going to tell you is this PowerPoint actually comes from one of our high school teachers. So Gateway not only teaches these classes to you in college, but also teaches these classes to high school students, some people as young as being freshmen. Okay, so our Python courses are taught throughout our district, various different high schools. And this particular PowerPoint came from Lakeview Technology Academy, which is down in Pleasant Prairie, which is a Gateway-sponsored STEM high school. And so they teach these very same courses there. And one of our teachers who just retired, Pam C., created this PowerPoint that she uses in a few of her different classes. And my intent here is not to go through all the slides. I'm going to hit highlights to give you ideas. And then I'm going to show you my way of proceeding with the same materials. But one of the techniques that we use when we write computer code is we often have to get the problem written out, drawn out, or something, on paper, on screen, whatever, in general terms. And what I mean by that is so that you can look at it and go, first I'm going to go do this, and then I'm going to do that, and then we're going to connect this to that. And I have it written out here, so now I can sit down and code and kind of know where I'm going. And if you think about building a house, going back to that analogy, it's the same way. I mean, I could speculate and say, hey, I'm going to need 100 2x4s, some sheets of OSB, about 3,000 3-inch nails or whatever, and I'm going to get busy building this house, right? But the reality is, if you ever look at anybody that's ever building a house, no matter how primitive it is, they usually have something written out. They figured out their measurements, they probably figured out the materials, they figured out the heights, the widths, what the codes are, what materials are appropriate to use in certain situations. They don't proceed willy-nilly because it's foolish to, right? You're going to end up spending a lot of time and money wasted to try to accomplish something where you could really shortcut things and get right to the crux of it by just thinking about it in advance and planning. So the planning part is really critical. And when we code, that planning process is usually done with something that we call pseudocode. And that's the word that you're seeing up on the screen here. So let's talk about the word pseudo. Pseudo means it's like code, but it's not. So we're kind of, insinuating what the code might be without actually writing it. And so that can be in something that does look like code or something that's similar to code and just plain English. I'm not sure how to code this, but we should do this here. Like, get the user's password would be a smart idea, just as an example. All right, so since we're talking about like the three different methods, the first one that we think about is what we call sequential or sequence. And so just like the recipe thing that we're going to look at in a little bit, a lot of times the set of instructions really is very sequential. You go to your room, pick up your clothes, take a shower, go to bed, in that order, or whatever your task is, so that you can accomplish what you want. So you do this, right? You execute the first statement, then you do something else, and then you do something else. And then we're done. That's how we get it done. And sometimes it's just that simple, even with a computer program. We do this, 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 and that, and we're done. And let's feel fortunate if we get to that point where our programs are that simple. Now, much more tangibly, and this is pretty important here too, because you're going to see this theme that forms with computer programs. With computer programs, very often we start with some sort of an input. We're either prompting our user, or we're starting with a piece of information or a premise. Then we will typically do some background operation. We will do mathematical calculations, we will do comparisons, analysis, whatever it is. And then after we figure out what we need to figure out, then we move to the output stage and show the user what was accomplished. And so you see this stream happening at the same time. And the basic pattern of it is what we call input, processing, and output. And those are good ones to write down, by the way. So to give an example, and she does this nice thing where she has these slides set up so she was hitting a button and just kind of walking through them. But she's talking about when you're doing pseudocoding. So if you're doing this for a computer program, typically it's a good idea to indicate we're going to start here and we're going to stop here. So there's always a start and a stop. Now with the recipe, you're not going to do that really with the recipe. But if you're doing it for a computer program, you will. So we're going to start whatever we're doing at this spot. We're going to end it here. I want to see what the clear start and finish is. All right. Then we look at the statements that we create. Everything is done in order. So sequential is exactly what it means. First I do this, next I do this, next I do that, and then I'm done. All right. So here's a little silly example that she has. She says, put your underpants on, put your pants on, put your shoes on. That makes a lot of sense, right? Unless you're wearing shorts and you can put on the shoes first, right? But generally speaking, that's a good order, right? If you're getting dressed from the waist down, put your underpants on first, put your pants on, and then put your shoes on. It usually works best that way. And I think most of us can agree, right? That's probably how we do it. So that is a logical answer to solve that problem. So this next one, the bottom half of the screen, she's giving an example. She says, get the first number, get the second number, add the two numbers together, display the result. Now it would be really easy to see that you can't really add the two numbers together until you have them, right? So that can't go up at the top. And I can't display the result until you add them together. So this order must work this way. The only order that could change here is I could get the second number first and the first number second, and I could still add them together and display the results, and it wouldn't break anything. But otherwise, the adding and displaying has to happen in that order, otherwise it's not going to work. So these are the kind of things that we start thinking about. So how can I add these together if I don't have the numbers, right? So that's what you ask. All right. All right, so this is one of these little exercises. I'm not making you do this, but she makes her high school students do this, right? But something you might want to think about. It says, try this, write the pseudocode, a program that gets a dog's age in human years and then displays the dog age in dog years. So what do you do first? Well, that's a really easy answer, right? The thing you do first is you have to get the dog's age in human years. So how long has your dog been around? I don't know, 10 years, right? So then how do I determine what its age is in dog years?
Multiply 7.
Right, so you multiply by 7. It's considered basically that 1 year of human existence is equivalent to 7 years of dog existence, meaning dogs don't live that long, right? So if they're 10 years old, they're like an old person, And now I've had dogs that have lived almost to 20, so that would make them pretty old, right? But that's the calculation that we use. But if you think about the process of that, first you have to get the real age in human years, then you have to do some math, then you put the results on the screen. You cannot do it in a different order. It won't work. That's what pseudocoding is about. You have to figure out that order. And so here's the solution to that. Right, so get the dog's age, multiply the dog's age by 7, put it on the screen. Notice the start and the stop at the beginning. All right. The next tool that we have to solve problems is one that we call repetition. And sometimes when you're working on a problem, there's an aspect of solving it that requires you to perform that task or that step over and over and over again until you've completed it. So the one example that I might give in this situation is maybe I'm making chocolate chip cookies for my recipe, right? And one of the steps is when the batter's all set to go, that I scoop up a spoonful and drop it with another spoon onto a cookie sheet, right? Well, I'm not just going to make one cookie. I didn't go all the trouble for one cookie. So now I'm going to do that over and over again on the cookie sheet until the cookie sheet is filled. It's the same step, but I'm repeating the process in order to get to cookies, right? So after I repeat putting the cookies on the sheet 20 times or whatever it is, then I put it in the oven and cook it, pull them out, take them off the rack, cool them down, serve with milk and enjoy, right? And these are the kind of little things that you're thinking about as you're doing it. So the interesting thing is repetition will happen in a couple of different ways, and we'll learn that when we get to those chapters in the book. But the concept is pretty much as simple as what I explained. Sometimes when you are performing a set of tasks in a sequence, there are certain steps that just repeat. And that's just part of solving it. That's just all there is to it. She goes kind of like into nice detail here with the slides. And typically when we're doing this thing, she'll, or we will look at this and say, while a condition is true, we'll keep repeating the step. So if I was making cookies, if it's true that I have batter left in the bowl, I have not finished putting them on the cookie sheet. So I will keep repeating putting cookies on a cookie sheet while there's still batter in the bowl. When that's empty, I'm done. See, that's the thinking here. All right? And now, when we're coding, this stuff will be indented, but that's a separate thing. Right, so she gives a Lakeview example. And I'm just going to move on. All right, so the next tool that we have in programming is one that we call decisions or selection. It's kind of known by the same thing. And what we're doing is basically, you might get to a fork in the road when you're basically making a set of instructions for a program. So for example, let's say you've come to my website and you need to get a piece of information. But I'm not going to give you that piece of information until you sign in with your username and password, right? So if you've signed in with your username and password, and they're correct, right? Then you can go ahead and look at the stuff. If you have not, well, you don't get to. It's as simple as that, right? So very often in a program, you'll be in the position that the statement that you make or the step that you make is dependent on something. So for example, if I'm making those chocolate chip cookies, I might get to a point where it's like, if I like to add pecans to my chocolate chip cookies, then I will add them, but I have to have them. So if I don't have pecans, I cannot add them to the cookie. Does that not make it a cookie? Well, no, it'll still be a cookie, but it'll just be a cookie without nuts. But if I have the pecans and I like them, I'm going to add them, and now I have a cookie with pecans. And so very often in programming, this is the thing that we do. In some situations, the choice is one or the other. In other situations, there might be 50 choices. Think, for example, if you're filling out a form online and you're putting in your name, your address, and whatever city, state. Now you get a drop down of like 52 states and maybe a few territories or provinces or something thrown in. Well, now you have an if or a selection that has like over 50 options, and why is that important? Well, it might affect your shipping or whatever it is you're doing online. So this is stuff to think about here. And that's as far as I'm taking this little lecture, but those are the three main mechanisms that we use. So now I'm gonna do a little bit of a demonstration that will help you guys get on track to work on the homework. So the first thing that we're gonna do is let's look at what the assignment is. And I know I have this pretty far zoomed in, but the assignment's gonna be create pseudocode to describe the steps in creating your favorite meal. All right, so the first thing I'm gonna say is, if you're not a cook, because some people are like, but man, I don't cook, so I don't have a recipe, right? It's like, well, you know what? I cook for everybody at home sometimes, and I hardly ever follow a recipe for anything. I just kind of, if I'm making, omelets, I kind of know how to make them, So if you don't have a recipe, ask somebody in your family for one. And the point isn't that you're creating it from scratch. The point is that you have a set of steps that you can put into a document to show proof of concept. All right, so it says, create pseudocode to describe the steps in creating your favorite meal. Think about what your favorite home-cooked meal might be, then find a recipe online or from whoever makes it for you, and then convert the recipe to verbiage in sequential order. So I'm not really looking for decisions, and I'm not really looking for repetition in this. I'm just looking for a step-by-step, okay? Create this as a Word document or directly within the right submission area of the assignment upload. So I'm going to talk about both of those things here, kind of wrapped into this discussion. So the first way that you might do it is like this. You might click the title here, and then as you get into the assignment, you'll notice the due date. So this isn't due till next week, Friday. Wait, no, this Friday. Oh my God. Right, so here's the thing. You guys should be able to knock this out in like 20 minutes anyhow, right? So you'll be fine. And there's 3 points for this assignment. Now you can use this right submission button, and I think I demonstrated this last week, but why I like using this tool is because it has a rich text editor right here. So you might say, you might come in here and say chocolate chip cookies might be your recipe title. Step 1, preheat the oven to 350 degrees, right? That might be, right? And then the next thing might be, step 2 might be gather, and you should use proper sentence structure here. All right. Now, a lot of recipes will also have a list of ingredients at the top, right? So you might want to include that. So for my cookies, I might go like this. I might say ingredients, flour, eggs, butter, sugar, chocolate chips, I'm trying to think here, vanilla, baking powder, maybe something like that. But you might list your ingredients, then list your steps. And you know what? Look at other recipes for inspiration. So, if it helps, hey, look up Betty Crocker and look up the chocolate chip cookie recipe and see how they list it, And the point is, it will give you all the steps, step by step, for making the food. Heck, look at a box of mac and cheese. If it comes down, if that's your favorite meal, and it might be for some people, what are the steps for making it? So those are the things that you need to think about. And then if you complete it here, all you have to do is make sure it's typed in correctly and hit submit. Now, what I would prefer that you do, though, that is one option. You can turn it in that way, and I'm fine with it. But I do mention here that I'd like it as a Word document. And then we get into this question of like, well, I just started here. I don't have Microsoft Office or Microsoft Word, so sorry. No, you do. Go right ahead. So let's talk about that. When you guys are logging into any of your gateway services here, you will at times go to your My Gateway account, just like I'm doing right now. And I do want you to notice that you can, right here, go to Office 365. And I don't know if I talked about this last week or not, but once you get into Office 365, you have a free account here. You can click on the Word document app, and Microsoft Word will come up right in your browser, and you can create a blank document right from here. You notice I'm not installing anything, right? I'm just using it in the browser. And then I might start to type my recipe here. Now, when I finish this, I would come up here to the File menu, and I would save it, and it would save to your Gateway account, or you can export it in a different number of ways. But what we're going to do is save as, download a copy, and then that will come to your machine as a Word file. Then you take that Word file, which of course comes up here, and then submit it in Blackboard. So if I was submitting a Word file in Blackboard here, I would click the title, and then I would come down here to the attachment pane, which is this dotted box, and then I can either just drag and drop the file here. So you see how it turns purple when I drag it over? You can do this. Or you can browse your files and attach it. But once you do have it attached, it will show up as attached file here, and then you hit submit. Now, I prefer to receive it as a Word document for a lot of reasons. The main reason is, if you do that, for me, it comes up in Blackboard automatically for grading, and it's really easy to see. Now, I know there will be some of you here that are like, you know what, I don't like using Microsoft Office or whatever. The one thing I will tell you is, first of all, you're getting it here for free, right? So it is available for free, and you don't even have to install it. It just works right in your browser. If you do want to install it, I want you to notice that they do have this button up here, which allows you to download and install Microsoft Office on up to 5 different computers for free, right? As long as you're a Gateway student. Pretty good deal. Microsoft Office still is considered the preeminent office suite in professional environments. And walking into any job where you sit down at a desk in front of a screen, they pretty much expect that you know Word, Excel, and PowerPoint, at least on a rudimentary level. And so if you've never used these tools before because you never had to, I might suggest that you explore and install them just so you learn them. It's good to know, even if you don't prefer them. All right, but let's say that you really are anti-Microsoft, or maybe at home you just have a Chromebook you're working on or whatever, and you need to get a document out. The other option is to go to your Gateway email account. And when you're in your Gateway email account, you bring that up on screen. Up here we have what we call the waffle icon, this little series of, I guess, 9 little dots. And from there you can go right to your Docs or your Drive and create a document from there. So I'm going to click on the Docs icon, and then I'm going to create a blank document. And you can see how now at this point it's almost just like working with Word in the browser. Here is a document on your screen, all the familiar tools that we have for working with word processors, and then you can just start typing up your recipe here. When you're all done with whatever you're typing up, you'll come up here to the File menu, and you'll choose Download Microsoft Word. You guys see that? And then that will also pull the document down to your machine. And then when it comes time to submit it in Blackboard, once again, you can use that drag and drop feature, just pull it into that box. Or you can browse your local files, or if you have it in your Google Drive or whatever, you can put it there as well. My favorite way to do it, real frankly, is I like the drag and drop, because that the box turning purple is pretty clear that it attached. Now you can see I have 2 documents attached. And when you're all done, you just hit submit, and then I will receive it. What will happen in your gradebook is once you do that, you will get a yellow, or actually more like a gold colored circle in your gradebook. And I'm going to show you that. So that'll appear here where it says my grades on the left sidebar. And then wherever you submitted that, and for this one, it will be pseudocode recipe, you'll have a gold circle here, which means you've successfully submitted it, and it's just waiting for me to grade it. When I grade it, you will get a score here in place of that circle. Right, so that's the procedure. But I will many times ask, depending on the assignment, so that's why it's always really important to read what is being assigned and what is being asked. Create this as a Word document or directly within the right submission area. Either one of those choices is fine. But I don't care if you use Google Docs to create the Word document. I don't care if you use Microsoft Word to create that Word document, but if you're going to turn in a Word document, you have to get it into that right format for me to see it. But I am giving you an option here to use the right submission area. But instructors ask for things a certain way for a reason, because first of all, I want to see that you know how to use the tools. So I want to know that you can get to Microsoft Office or Google Docs and create a Word document. It's a very important skill in life. And then I also want to see that you're following the directions, because I don't just give the directions for no reason. It really helps me to grade, which is why I ask for it in that format. When you turn it in some other format, so invariably I might get somebody that types it up in something else. Chances are I could probably still open it, but Blackboard won't open it natively. It does beautifully with Word, Excel, PowerPoint, PDF, and a couple of code formats, but very few, where it just shows it right in the window for me. I don't have to download, open it, examine it, and then grade it. It's in Blackboard. And that, to me, makes it a lot easier. And once again, folks, it's critical that you know how to work with a Word file. It really is. Okay, so this class is not about Microsoft Office, but we kind of make a lot of assumptions about skills, and that's an important one. And so that recipe, for most people, will be a pretty basic document. For most people, you can fit it on one page. I do get people that are like, oh, I'm going to do like my grandma's secret recipe for ribs or something. It'll be 3 pages long. Yeah, I'm not trying to kill you here. It can be a simple one. I just want to see that you could put something in a step-by-step format verbally. That makes sense. So recipe is actually a good way to start. All right. So let's talk now about an additional piece of this. And I'm going to bring up regular Microsoft Word here. And I'm going to talk about this other aspect of pseudocoding, which is what we call flowcharting. And so the reason I'm bringing up Microsoft Word is because Microsoft Word does have built into it the ability to create graphics within it, not just words. And so for right now, I'm going to cut back here, and I'm actually going to go to, if I can find one of my old Java Programming 1 classes. And rather than describe what it looks like, I'm going to show you a real living example. So if you might happen at some point to take the Java Programming 1 class with me, or you're taking it with somebody else. Here's a living example of, in my Java Programming 1 classes, I assign a final project. And we start taking that final project and we start breaking it down into logical components. So we start thinking, okay, we're going to write a program that surveys people about current news topics to get their opinion. So how does that work? And so you can see here with a combination of kind of flowcharting and regular pseudocoding with plain words, we first figured out that we're going to break the program into a few different areas. First, one part is to take the survey. The second part is to display the results of it. Third part is to be able to edit the entries. And so, all right, so those seem like 3 separate functions, so we'll break the program into 3 pieces. From there, if I want to just take the survey, well, how do I take a survey? Right, so you start thinking about it, and it says, display the questions and answers, or the questions and possible answers. Get the input from the user. Is that input valid? If not, you ask them again. If it is valid, you move on, and then you say, all right, well, you made your choice. We're going to keep track of the response, and then we'll go back to the main menu. That's one aspect of the program. Now, it doesn't write the code, but it gives me the procedure of how the program operates sequentially for that aspect of the program, right? Now, you can break that down and look at all the other aspects of the program, but then we start to also flowchart it on the far right side. And I think this is really kind of neat because we did this in a live classroom as I was demonstrating how to build a project. And with this flowchart, what I was showing the students is that as your program starts, there's a bunch of stuff first that happens in the background the user doesn't even see. And then the first thing the user sees is the menu. So a menu comes up on screen and they're like, all right, do you want to take the survey, look at the results or whatever? And then because it's a sequential step, it moves on down to this level here, where we then get input from the user. Then we use a slightly different flowchart shape, which I did horribly here. It's supposed to be a parallelogram, but whatever. Once we have the input, we check to see if it was correct or not. So here's a decision point. So true or false. And if it was not correct, then they go back to the menu. If it was true, then we tally the results and keep track. But there's a flow that happens in the program, and your recipes are very much like that, right? So if you're doing a recipe, what'll happen is all of your steps will look pretty much the same, and because they're a sequence. If you're doing something that's got a little bit more complexity to it, then chances are you will use different shapes. So I'm going to go back over to my Python class. See, I'm in my Java class right now. Back over to the Python class here, and then I'm going to look at this little graphic that I have here on flowcharting. So if you are to take whatever thing you're working on and it gets more complex, we like sometimes to look at it visually because it helps us see where we're going. Kind of like I could verbally describe the blueprint for a house in sentences. Like, you're going to build the outside wall this big, this tall, this kind of wood, whatever, and I don't have to make any pictures of it, right? But it's so much easier if there's a graphic and I can see what you mean. So that's what a flowchart does for us, because we can see the flow of the process of the whole thing. And so when we're using flowchart shapes, and there's some basic ones that we use for programming, the first one is the arrow, which shows how we're moving from step to step. Usually when we're flowcharting, we start at the top and move to the bottom, or we start at the top left and move to the right. It's one or the other typically, but it's that kind of a flow. It's either top to bottom or left to right, depending on how much room we have. The rectangle is always used for what we call processing steps. So in other words, not stuff that the user interacts with, stuff that's happening in the background. So for example, if you're calculating the dog's age, that would be in a rectangle because it's a calculation. The user doesn't see it, but it still happens in the program. The parallelogram, so it's kind of like a rectangle, but the sides are on an angle, parallel angle. That's used when we are interfacing with the user. We're either getting information from them or we're putting information back on the screen for them. So those are used for input or output statements. The diamond shape is the one that we use for making decisions. So in this case, the example says, is the area greater than 100? And that's either true or false. It either is or isn't. And then depending on what the answer is, we'll go one way. If it's greater than 100, we'll go another way if it's less. And then we follow the steps that follow. But those are the basic shapes. Now, I have included here as kind of a extra credit is that you can create a flow chart for your recipe. But the thing that we're going to do next week, so I'm going to have you start with a recipe, and then the following week we're going to work on a flow chart for a problem that really is more of a programming problem. And I just want to double check the due date on this. All right, so it is next Friday. So we'll talk about this one next week in class a little bit. But the way that, if you guys feel ambitious here and you want to kind of move forward on this one begins by looking at this document. And so the document will describe a programming problem. I'm just going to show you how this is. And this is the part where people go like, oh man, this sounds like a math word problem. You know what? Because it kind of is. You know, I mean, that's the reality of it. But these are the kind of situations programmers are presented with, right? So I will revisit this next week, but I'm just giving you a little bit of a preview. So here it says, John needs to determine how much liquid fertilizer he must buy for application on the client's lawn. The client's lawn is rectangular and measures 30 feet by 50 feet and totals 1,500 square feet. The instructions in the bottle of fertilizer indicates that it needs to apply 1 gallon of fertilizer for each 9 square yards of grass. Right, so we figured out the area in square feet, but the fertilizer is in square yards, right? So there's one problem to solve right there. And then, so he has to figure out how to convert all this, and then he has to figure out how much fertilizer he has to buy. How many jugs does he need to get that whole lawn? Now, you don't want to buy less because then you might not have enough. And if you buy more, you can save it for the next job, right? So if the job calls for, let's say, 5.5 gallons, you buy 6. You don't want to fall short. You want to have enough, and then that extra half gallon can be saved for next time. Okay. And some basic calculations are given here. And then what I've done, and this is kind of the fun part here, here is the actual solution in pseudocode of how to solve the problem. And your job will be to take that solution and convert it to a flowchart. And I will show you how to do that next week. We're not going to do that today. We're going to do that next week, just so you guys see how it happens and you can ask questions and stuff. If you feel ambitious, because I think the recipe assignment is honestly painfully simple, please proceed and move forward and try to do this one. And what you'll notice is, for example, there's certain steps like get the lawn length from the user. So like how wide is the yard or whatever. That's an input from the user, so it goes into what shape? The parallelogram, that's an input statement. If we're doing a calculation, happens in the background, that goes in a rectangle. There's no point here where we have any decisions to make, so the whole thing can be done with rectangles and parallelograms, if you think about it that way. If I was to make one for a cookie recipe, so now I'm going to demonstrate how to use the tool. So I'm going to bring this up in Word. I guess I already have that open, but let's create a new document here. If I was to create this in Word, I want to point out to you guys that there are these really kind of neat tools that are built into Word. First of all, you can like draw in Word. Not that I recommend straight up drawing here, honestly. But if you use your insert menu on Word, you will notice that they have an item for inserting shapes. And if you click on it, well, hey, look at all those shapes that you can throw into your Word document. And the first thing you'll notice is, hey, there's a rectangle, you know? So there's a rectangle. And hey, there's an arrow. So I can easily just draw an arrow, for example. So like, for example, if I'm working in this box here and I have it active, I can just type into it and I can say, get length of lawn. And actually, that's an input statement. I might say calculate area of lawn. And in fact, you might even do it differently. You might just say area of lawn equals length times width, because that's the calculation that happens. And the whole procedure here basically is that you take the steps that you're doing, convert them to the right shapes, connect them with arrows, and put it on a sheet of paper. If you use Microsoft Word, those tools are built right in. Every once in a while, we'll get somebody that's like, you know what, Ty, I'm fumbling with Word, I'm not getting it. Can I just draw it on a piece of paper, or can I use a graphics program to do it? Sure, you can. You can do it that way if you want. I would really strongly prefer that you learn how to do it in Word. Those of you that might work with the Google Docs tool, by the way, just know that if you're here, you can basically do the same thing here as well. I'm not sure where they add those tools here exactly. I think you go to drawing and then you start adding your shapes here. Yep, there you go. And you notice how they look very much the same, you know, between the two different tools. Get this thing to rotate here. But just gives you the idea that you can do that pretty easily in the Google tools as well. For my money, frankly, folks, I think that Microsoft Word is a much better tool. It's a more professional tool, but you certainly can do all the work with the Google Docs platform as well. Right? So the recipe is a pretty easy one to do. The fertilizer problem is a little bit more involved, but we will revisit it next week and we will go through it. This is also fairly well recorded in the existing video that's already in the unit folder here, so you can look at that as well as a guide. Let me ask really quick before I move away from this, are there any questions about any of the things that we're doing here so far, or how to get any of it done? You guys cool? All right.
I already submitted the tool, which is telling me that, you know, not even wrong, but then it's on the process that,
Right.
I'm taking a look at it.
Absolutely, absolutely. No problem at all. And that offer stands for everybody. The question was, hey, I already did this and submitted it, and now I'm realizing it might not be exactly right, or it might not be how you want it. Can you take a look and let me know? Absolutely. And that's one of the advantages of getting the work in early, is we can do that without any point penalties of any sort. But if you are stuck or you're not clear, just reach out to me and I'll help you figure it out. This is kind of one of those things that in some programming paradigms, I'll put it this way, like you go to some four-year institutions, they'll have entire courses on pseudocoding and flowcharting before you learn how to code, so that you get the logic of it before you start to write the code. I'm spending 1 week on it, you know, and then you'll see that it just kind of applies to everything you do automatically, and how you choose to employ it is really up to you. The reality is a lot of programmers really sit down and, like what I showed you, where they use like a whiteboard or something and write out all their ideas before they start to build something, because it's really hard to build something complex without a plan. It's just a simple.
Any other resources? One of the things I'm having an issue with is breaking down the problem. I'm either breaking it too far down, or I'm not breaking it down far enough. Do you have any resources to sort of get up in that mindset?
Well, I'll tell you what, it kind of comes incrementally. All the things that we're going to work on in the first couple of units are going to be so simplistic that you will not need to pseudocode it. I mean, because it's that kind of simple. When it starts to get more complex, what I usually advise people is, well, think of what this involves. Is there math? Are there formulas that we have to worry about? Is there interface with the user? How are you going to handle that? So as soon as you start identifying that pieces are different, so one is doing math, one is interfacing with the user, well, I'm going to handle each one of those things differently. And professional programmers will do exactly that, where you're going to have people that just do interfaces, you know, like here, this is what we'll ask the user, and the other people, the scientists, are working out all the formulas, right? And that's the thing that I think also freaks people out too, especially when we start bringing math in, is people are like, I'm not good with math. I don't like math. I hate math. I'm programming because I don't like math, you know, whatever. Math is just a tool, and most of the time the formulas will be given to you. If they're not, then really all it takes is usually a little bit of research to figure them out. We're not trying to make you high-end mathematicians here in these classes, but you should know that as programmers, if you want to make this a career, and you start going into, let's say, a four-year school or beyond, you take a lot of math when you do computer science, because the two fields are tightly related. And you know, for example, when I did my master's degree, I think I earned 21 graduate credits in mathematics alone. And because of it, I can teach math if I choose to, and I have done that. But it really isn't about the fact that you're doing the math. It's more about the process of how do you solve the problem. Often, a lot of problems in programming cannot be solved without math or logical comparison. All right, folks, we're about an hour in already. That's how fast class goes. So we're doing a 5-minute break right now. This video will stop here, and then I'm going to do a separate video on doing the install of the software. That's what we're going to be doing next. So people at home too, take a 5-minute break, and we will be back shortly.